Good morning. So while solving problem, you are facing problem where that is when monoatomic, diatomic or triatomic gas is there. What is Cp value, Cv value and gamma value? Okay. And du by dq also dw by dq, what we have to substitute in terms of gamma? That is basically the question. So for that, I am going to give you one table which will give you some ideas as well as some values, that which formula where you have to use and what is the value of gamma particularly, as well as Cp and C. Let's see. So see here, Cp comma Cv and gamma values for of different gases. Cp, Cv and gamma values of different gases. So let's make one table. This is serial number. Then this is for Cp. This is for Cv. This is for gamma. One is serial number. Second one is atomicity of gas. Next is Cp, then Cv, and gamma is equal to Cp by Cv. Serial number 1, monoatomic. First one is monoatomic. For monoatomic gas, Cp is equal to 5 by 2 R. Okay. For monoatomic gas, Cp is equal to 5 by 2 R. Cv is equal to 3 by 2 R. Keep it in mind, always we have learn one relation. Cp is greater than Cv, always. So the greater value is for Cp and Cv is less. And gamma is equal to ratio of this. If we will do, then you are getting it is 5 by 3, that is equal to 1.67. Next one, second one, that is diatomic gas. For that it is 7 by 2 R Cp value. Then this is 5 by 2 R, and this one is 7 by 5, that is also equal to 1.4. Next one, try non-linear and polyatomic. Triatomic but non-linear. and polyatomic. For these two, you are having same Cp, that is Cp is equal to 4R and Cv is equal to 3R, and this is equal to 4 by 3, that is equal to 1.3. And last one is trilinear. This is tri-non-linear. This one is trilinear. So for this you are having Cp 9 by 2R, okay, just value is enough, no need to write again Cp and all in the table. Here is 4R, and this one is 9 by 2R and 7 by 2R. This is 9 by 7, which is equal to 1.29. Okay, so whenever you are solving problem, this table is very useful for substituting either Cp, Cv or gamma values. Okay, so note down this table. Okay, next. Now, one more topic, that is sometimes they are asking this gamma of mixture of gases, or even you want to find du by dq, fraction of heat absorbed. In yesterday's problem we have seen, okay, or else even fraction of work converted into heat. One problem I have sent you on group, that is dw by dq. So there 1 minus 1 by gamma, how it is coming, I already showed you one derivation also, but still I am giving you. So see, gamma of mixture of gases, gamma of mixture of gases. So number one, when n1 moles of gas is mixed with n2 moles of another gas, is mixed with n2 moles of another gas, then first of all Cv of mixture, precipitated partial volume for mixture, is equal to n1 into Cv1 plus n2 into Cv2 divided by n1 plus n2. Okay, next one, Cp of mixture is equal to Cv of mixture plus R, because you know Cp minus Cv is equal to R. So therefore, this formula either use or like this, N1 Cp1 plus N2 Cp2 divided by N1 plus N2. And gamma of mixture is equal to Cp of mixture divided by Cv of mixture. So first you find out this Cp and Cv for mixture particular, and then you can use it. And so therefore, if we will use this, then we will get N1 plus N2 divided by gamma mix minus 1 is equal to N1 by gamma 1 minus 1 plus N2 by gamma 2 minus 1. So these formulas you can use whenever it is necessary. Okay, according to the given things, you can use these formulas for mixture. If you want Cv, you use this formula. If you want Cp, you can use this. Even if you want gamma mix or N1 and N2 and everything, in terms of gamma 1 number of moles, you can find out this. Okay. If this formula when you will use, when gamma 1 and gamma 2, N1 and N2 is given, then you can find out gamma mix from this. If Cp and Cv of mixture is given, you can find out gamma mix. If Cp mix is not given, then you can use this formula. If Cv of mixture is not given, then you can use this formula, right? Next point, which yesterday we have learned. Yes, in the one problem which I have given in a homework. So in that, you see, at constant pressure, at constant pressure, you just keep it this in mind. At constant pressure, fraction of heat absorbed, fraction of heat absorbed that is converted into internal energy, that is converted into internal energy that is du by dq. While solving problem, you use this whatever I have given now. You try to solve the problems. Cv by Cp is equal to 1 by gamma, this formula. And one more, if suppose you want to find fraction of heat absorbed that is converted into external work done at constant pressure, that is also okay. Then which formula will you see? At constant pressure, at constant pressure, fraction of heat absorbed that is converted into external work done, that is converted into external work done is dw by dq, that is equal to nr dt divided by ncp dt. Then this dt and this dt cancel, this n and n cancel. So what is left? R by Cp. Yes or not? And if you will substitute here, R is equal to what? Cp minus Cv divided by Cp. Then you will get 1 minus Cv by Cp, because Cp minus Cv is equal to R. And then you will get dw by dq is equal to 1 minus 1 by gamma. है ना? Because gamma is equal to Cp by Cv. Here Cv by Cp is there, so reciprocal of it. That's why 1 by gamma. Okay. So this will help you while solving the problems. Right? Note down this all. Okay, next one. Let's move for next topic, that is entropy. What is that? Entropy, and denoted by yes. Entropy is denoted by yes. It is a parameter or thermodynamic parameter. Thermodynamic parameter. What is this entropy? It is a thermodynamic parameter which gives measure of disorder, which gives measure of disorder. This is what your entropy means. Next one. Point number one, we can't measure entropy, but we can't measure entropy, but we can measure change in entropy. But can measure change in entropy during thermodynamic change. During thermodynamic change. So here ds is change in entropy. It is equal to dq by capital T. This is what change in entropy. Where ds is what? ds is small change in entropy. Small change in entropy at temperature capital. And dq is exchange between heat, surrounding and temperature. dq is exchange of heat between surrounding and system. System and surrounding. Exchange of heat between system and surrounding, or surrounding and system. System and surrounding लिखो. You write between system and surrounding. Okay. At temperature T. Total change. Second point. Total change in entropy. That is delta S is equal to integration of dq by dt. You have to use this formula. Okay. Next point. Change in entropy during isothermal change. Change in entropy delta S is what? dq by t, है ना? Delta q by t, that is equal to what? Delta w delta Q by T is equal to delta W by T. So what you will get? You know, work done in isothermal change, what is that? 2.303 nRT log to the base 10 P2 by P1, and this is divided by T. So this T and this T will get cancelled. So you will get delta S is equal to 2.303 nR log to the base 10 P2 by P1. Okay. Next point, that is entropy during phase change. Entropy during phase change. During phase change means what? Suppose water at 100 degrees Celsius is going to convert into steam at 100 degrees Celsius, or else ice at 0 degrees Celsius is going to convert into water at 0 degrees Celsius. Then which formula we will use for change in entropy? Then delta S is equal to this delta Q by T, and delta Q, you know what is the formula? ml during phase change. Therefore this formula you have to use ml by T. Next, if suppose temperature change is there, so change in entropy during temperature change. If suppose they are giving in the problem that change is there in temperature, then which formula will use? Delta S is equal to m into integration of S dt divided by T. This is nothing but just delta Q is equal to ms delta T. Okay, shall I repeat one more time? Wait, I will tell you how you are getting this formula. So basically first you are getting this, everything is delta S because you are finding change in entropy during that process. So direct without wasting time, delta S is equal to, you are getting delta Q by T, that is also integration. So delta Q is equal to ms dt, okay, and divided by T. Just m I am taking outside, and you are getting S dt divided by capital T. Okay, understood? Right? Some note points regarding this entropy. So this is number one, that is in a reversible process. In a reversible process, entropy increases. Yes, increases. Yes means what? Entropy increases if heat is absorbed. If heat is absorbed, and decreases if heat is released. So therefore I am writing just vice versa. Okay. Second point, entropy of universe. Entropy of universe always increases. Always increases if system undergoes an irreversible process. If system undergoes and irreversible process. And third point, entropy of universe can never be zero. Entropy of universe can never be zero. Okay. So this is what about the entropy, right? So note down this all. Okay. So let's stop here for today. And please revise the problems, whatever I have given. Please solve that all. Okay. So bye for today.